degrees. Kelvin just has a K. All right, so when we go to solve this today, K equals C plus 273. So we're looking for K. This should have been an easy one because you'd have just said 25 plus 273, and you would get Kelvin equals 298. And to answer Emma's question, in case some of you did not hear me, K is the only temperature unit that does not get a degree symbol. Celsius is degrees Celsius, Fahrenheit is degrees Fahrenheit, Kelvin is the only one that does not have it. It's just a K. So you just write 298K. Okay? Questions about that? All right, number 2, you have 200 Kelvin and I want Fahrenheit. Do we have a formula that goes from Kelvins to Fahrenheit? No. So in this case, you're going to have to do what? Convert from Kelvins to, and then Celsius to Fahrenheit. So we're going to need 2 formulas here. So we're going to use our Kelvins to Celsius first, like you said, and put 200 in for Kelvins. So we're going to get to do what here to get Celsius? The calculators are expensive. Try not to drop them on the floor. So we get Celsius equals negative 73 degrees Celsius. Everybody okay with the first part? All right, the second part has a formula of C equals 5/9 F minus 32. And like I told you many times, you can solve this any way you like to. It doesn't make any difference to me. You choose based on your math abilities. If your math abilities are such that you're like, I want to multiply by the reciprocal or the multiplicative inverse, by all means, do that. Whatever floats your boat. Okay? If you have weaker math skills and that just doesn't work for you, then do what I told you. Cross multiply and get rid of that fraction so that you don't have to deal with fraction. All right? 73 times 9 is going to give us negative 657 equals 5 times F minus 32. Now, my experience has been that once most people get rid of that fraction, they're home free. Now, you can choose from there. Divide and get rid of the 5. Distribute, you choose. Whatever you see based on your math class. What does your brain see first? Does your brain see divide by 5 and get rid of the 5? Does your brain see distribute the 5 through the parentheses? What do you see? And then do that. Well, yes, you see numbers. But most of you have been in math class. What math are y'all in now? Pre-calc. All right, y'all are well past Algebra 1. All right, most of y'all did this back in middle school somewhere. So y'all have been doing this for years. So what do you see when you see that? Do what comes naturally to y'all. Okay? You don't have to do it my way. Do it your way. When I look at it, I see divide 5 first. Some of y'all saw distribute yesterday. Do what you see. You don't have to do it my way. Okay? I see divide 5 because I like small numbers. And then I add 32 to both sides. So I got Fahrenheit equals negative 99.4 degrees Fahrenheit. That's fine. It might be slightly different. If it's, what'd you get? Do you have work to go with it?
But I didn't. I just tried to see if I can plug in a value for the S minus 32 and then multiply that by.
As long as you have work that I can follow and the work is correct, then I would give you credit. Questions? All right, the last 2 are using your heat formula, right? So number 3, I've asked you to give me the identity of a metal. So if I'm asking for the identity, are we solving for the Q? Change colors. Are we solving for the Q, the M, the CP, or the delta T if I want you to find for me the identity of the metal?
CP.
We got to solve for the CP. That way you can look it up on the blue chart, right? All right. So, based on that, what do we know? Do we know Q?
We know mass.
Yes.
We know mass. Okay, so I know mass is 5.28. That's good. We know we're looking for CP. That's important. So we got to have Q and we got to have delta T. The temperature increases how much? So this is one we're not going to need to subtract because I just told you the temperature increased by 54.1. So we're not going to subtract there. Okay? So given that, what does that tell you Q is? 149 joules. All right. So from there, all we have left to do is solve. So again, you can solve it more than one way. When I look at it, I see combined like terms because that's the way I was taught when I was in middle school and high school. But if you've learned a different way, do it your way. 5.28 times 54.1. So when I do it, I get 285.6 times CP. 149. So I need CP by itself. So I'm dividing by 285.6 on both sides. So I'm getting CP equals, and I get 0.521. Now, I don't really need a unit on this. I don't really even need to worry about significant digits because is the question asking me for a number? No, it's asking me the identity of the metal. So it's not really important for me to have a unit in the significant digits. I need to go to my blue sheet and find out what element I have. Titanium? So my answer is titanium, which is why I said it's not really important for me to know my significant digits or my unit because I'm not finding that in this question. Now in the next question where it says how much heat, for me to know significant digits and unit because that one wants me to know a number. Everybody okay with number 3? Okay. Can I erase? All right, number 4 wants to know how much heat is lost. So what am I solving for in my formula if I'm solving for how much heat?
Q.
Solving for Q. All right, so what's my mass, Shatoria? All right, the mass is 55.6, which is what I asked you. That is correct. All right, what's my specific heat, Shatoria? Nope, I just asked you. Ashai. That's my specific heat in this question. Mm-hmm. So where is it? Or what is it? Nah, it's got degrees Celsius behind it. So it would be a temperature if it's got Celsius behind it. So that can't be specific heat. So where are we going to get a specific heat? Solving for Q. What are we going to do, Ethan? That's not going to give us specific heat. What are we going to do, Priscilla? For specific heat?
I don't know.
Lewis, what are we going to do for specific heat? David?
It says copper, and the blue sheet is 0.385.
All right. See how it says copper right here? Specific heat is on the reference table. So you got to get out your blue reference table, and you got to look up copper. Okay? Specific heat is not always going to be given in the question. So when you look it up, it's, what'd you say, David? 0.385. All right, and then times this number right here that has degrees Celsius on it. Degrees Celsius is always a temperature. Okay, it's never going to be a specific heat. So the temperature is going for delta T. So what are we going to do with those two temperatures? Subtract them. So we're going to take that 65.2 and subtract 23.7, and we get 41.5. All right, so 55.6 times 0.385 times 41.5, and I get 888.349. Now, do I need all those numbers? No. How many significant digits do I need in my answer based on the question? I need 3. So the easiest thing to do is to do what? Just drop off those last 3 numbers and just stick with 888. Now, once I've done that, what unit does Q get? It gets joules. Questions? Anybody? No? Can we talk homework?
Yeah.
Okay. We need to? Okay.
I did it.
All right, question number 1 has 3 answers. The first answer in question number 1, we got it in front of us, so I don't have to repeat 800 times. Question number 1 should be negative 59 for the first one, 318 for the second one, and negative 423 for the third one. Now, technically the third one is wrong because I gave you a question of negative 150 Kelvin. What's wrong with that? There's no negatives on the Kelvin scale. It's a typo on my part. All right, number 2 should be 81.2 joules over grams degrees Celsius.
Always forget.
The significant digits, so that you have significant digits, should be rounded to 1. So it should be changed to 80 for significant digits. I only rounded or gave you the answer for those of you who rounded wrong so you know if you had the right answer. All right, number 3. You should have around 92.1. When you round to significant digits, you should round to 90 joules. Number 4, you should get around 0.416. And in that one, you need, again, 1, so 0.4 joules over grams degrees Celsius. Number 5, we need 2. So you should have 10.7 joules. I'd round that to 11 joules. Number 6, I got 1,010 joules, and you need 2. So I'd either change it, you could round up to 1,100, which is really too high, or 1.0 times 10 to the third would give you the right number of significant digits, joules. Number 2 was 81.2, and you could change it to 80 to make 1 significant digit.
What was the second part of the first question?
318.
Wait, 5?
5, I got 10.7. So I rounded it to 11 to get 2 significant digits. What about the what? Look at the given data. You don't look at what you subtracted. You just look at the given data in the question. So number 5, you have 3 significant digits, 2, 2, and 2 significant digits. Don't look at what you subtracted to get. Look at what's in the question itself. How many significant digits are in number 5 and all 4 numbers that are in number 5? Okay? You don't look at your work. You look at what's in the question.
Wait, what?
She's blaming you for the significant digits.
He calculated 2 got the same thing as me.
Okay. Now, what questions do we need to talk about? Huh?
The second part?
All right, so I hear 6 in the second part of question 1. So in the second part of question 1, you have 45 Celsius, and you're going to Kelvin. So K equals C plus 273. So Kelvin equals, you got 45 plus 273. So unless I added that wrong on the calculator, 45 plus 273, 318. Okay. What I call out? 318. Punch it in again, Queen. You probably hit it wrong on the calculator.
Oh, and,
I said 318.
oh, no, I was looking at also the one below that.
Yeah, that one would.
I got one.
That one I had negative 150K. So just use what I had, even though it's a typo. Plus C, or equal C plus 273. So you subtract 273 on both sides. Subtract 273. And you know in math class, when you add two negative numbers, you're going to get a bigger negative number. You get negative 423.
Yeah, me too. I used to struggle in class.
Okay.
They wasn't playing.
All right. Number 6, you've got 75.0, which is 3, 15, which is 2, and 45, which is 2. So I'd round to 2. All right, I'm getting ready to do 6 for Shatoria. All right, so in number 6, you're looking for what, Shatoria? When it says calculate the heat, is that Q, is that M, is that CP, or is that delta T?
Q.
It's Q. Okay, so what's the mass?
75 point.
Okay, did they give you CP? So where do you find it? For iron, so look up iron because that's what they gave us.
0.429.
Okay, and then delta T, so what do you do to find delta T? Delta T is temperatures. Look at your problem. What do you do with the temperatures? Delta means change in, so what do you do with the temperatures? Subtract them. So you're going to take 45 and subtract 15. So 45 subtract 15 and we get 30. Okay. Now, this is a mistake Alexis made a minute ago. She wanted to take and say 30 was only one significant digit. Don't worry about that. You're using your 45 and your 15. So use the numbers in the question. So each of those had two significant digits. So that just go back to the original question to see how many significant digits they gave you, not your actual subtraction. Okay. And don't use the chart either. All right. So the numbers y'all look up at the chart, don't use that either to figure out significant digits. Use the numbers they gave you in the question. All right. So you had this, this, and this given in the question. So your answer is going to need to be rounded to what? 2.
Oh, 2.
Okay. So when we calculate this, we had 75 times 0.449 times 30. So I got an answer of 1,010.25. And I only need 2, so I know that it's gone. And so a lot of people struggle with how to get that to 2 significant digits because right now you have how many?
2, 4.
3.
3.
Yeah. There's 3. Okay. That right now has 3 significant digits, and you want it to only have 2. Now, some folks will go ahead and round that to 1,100, and I will take that because that has 2 significant digits, and it's fine. I'm not going to mark it wrong if you do that because you do have the correct number of significant digits. Technically, should 1,100 or 1,010 round to 1,100? No, that's really too high. The only way you can get that to 2 significant digits is really to put it in scientific notation and make it 1.0 times 10 to the third. That is the only way you can put that in the correct number of significant digits and make it a correct number. There is no other way. Yes, sir.
Question. Like, say for instance, like that problem.
Mhm.
Does it matter if it's like under the amount?
No, you could go under, but the problem is if you round it down to 1,000, you only have how many significant digits? Yes. Which is why I said you had to go the scientific notation route. Anybody else have a question on how to use the equation or plugging in the numbers other than just the significant digit issues? Or you feel all right over there? Guess I'm stressing your life out.
Who's stressing my life out?
Me.
Why?
I don't know. You said we need to go over homework a minute ago, so I figured
Oh,
there were some issues. You're okay?
I still don't even remember what I was gonna ask you, but I
Okay.
was down.
Yeah.
So you're okay?
Yeah.
When you see these next
I
week,
don't know.
so when you see these on the test either Friday or Monday, you're okay.
I don't know about test yet.
Okay. Okay. Moving on. So let's talk about a couple of vocabulary words that you guys should already remember from other science classes. All right, and these should be old enough, even if you had a crappy experience or a sub experience, you should know these from somewhere. And then we're going to talk about physical and chemical properties and physical and chemical change. Physical and chemical change are really the only parts that are my curriculum. Physical and chemical properties are really someone else's curriculum, but I don't know what experience you had in middle school, so we're just going to assume that you had a sub for everybody. Now, matter. Somebody tell me what matter is.
It can be
It's a substance.
yeah.
Need something a little more.
It can be in 3 different forms: solid, liquid, and gas.
It can. It has to have 2 requirements. And I'm looking.
Subspace.
Okay. Some space.
I will high five you.
Yeah, Mom, that was not necessary.
Has to
Please
take up
please
space.
control
Some
yourself.
people say it has to have volume. There's another way to say it takes up space.
Secretary.
No.
I was guessing that, yes.
It's something obvious.
It takes up space and
And it has space.
How obvious it is.
Has to have one other thing. What was that?
That's math.
Yes.
Oh.
I'm doing so well.
All right. Matter is anything
This roll every day.
that has mass and takes up space. Now, a lot of people will say volume instead of takes up space. So you could say has mass and volume. Now, if we were to make up a list, examples of matter and examples not matter. We should be able to do that pretty easily after being in science class for multiple years. So, if I was to say, give me some examples of things that are matter. Give me 3 or 4 things that are matter.
Okay.
All right, people. I heard chair.
Trash can.
Homo sapiens.
I think those are people.
Recipients.
All right, give me one more. People, chair, trash can.
To keep
What?
Water.
Sure. All right.
Water.
Give me some examples of things that are not matter.
Time.
Okay.
Whew.
Yes, you gotta think about this.
Helium.
air is matter, right?
And that is usually the one I get that people mess up the most often and want to tell me that air is not matter. But think about it. If you put, hold on a second with that one. If you put air into tires, does the tire expand?
Yes.
Then it takes up space. All right. A lot of people, when you blow up a balloon, it's not air, it's carbon dioxide, but does the balloon expand? Yes, that is also. So when you think air, think all gases, okay? Because air is a gas. Don't get those confused with things that are not matter. Gases expand. Even if you personally have gas, those things expand, okay? I know it sounds kind of gross, but those are examples of matter. They take up space. They may not have a lot of mass. The mass may be very small, but they have a mass and they take up space. So they're examples of matter. If we couldn't get those things to expand, could we have come to school today as easily as we did on a bus or in a car? Maybe some of you came on a bicycle. How many of you walked to school today? None of us, most likely. All right, so without air or a gas to inflate those tires today, it would have been a really rough ride. None of us came on a wagon with some seriously messed up wheels, okay? So, examples that are not matter. change that word slightly for me.
Eight.
Hate. Okay.
That was a good one.
I gave her the idea of everything.
All right, heat does not matter.
That's funny, yeah.
Think of things that we use in science class. Don't make up junk.
No, chemicals.
Yeah, we're gonna use those today. They fall on the other side of the board.
Matt.
Iodine.
Yeah.
Iodines matter.
Oh.
This is the first thing I did when I got here today. I walked in the room.
Huh? Light?
I want to.
Energy? Wait,
Ah.
True.
Change from
My
like.
hopes and dreams.
Some of y'all are making too much of it at the moment.
Laughter.
Okay, so that laughter is a type of sound.
Noise.
Noise is a type of sound. Sound does not matter. It does not have a mass. It does not take up space. Heat does not have a mass. It does not take up volume or space. Same with light and energy. Okay? We've got enough of that for the time being. All right, 2 words that I want to talk about the difference between, just to make sure you understand the difference, since we're going to use one of them and not the other this semester. Does everybody have what they need?
No.
Is it still 3 today for?
Yes.
Very hard.
Like
I thought it was
Comic-Con.
supposed to be in
Really?
the sixties today. and then
It's supposed to be about 69, and there's a good chance of rain today.
Like at one time. The rain would start.
Yeah.
Well, I pay attention to all that.
I'm ready for it to get down to like 50.
Oh,
Yeah.
Yeah.
Preach it, Emma.
I'm 50.
Come on, do a song. I hate the cold.
They have today 40% chance around 10, but lunchtime, noon, 1 o'clock, they have a pretty high percent chance.
One o'clock, 3
Dang it, 'cause I'm supposed to sit outside today. Why, you don't want to run in the rain?
Not looking like you got a really good chance of that.
4:30.
By 1 p.m., 90% chance.
Lovely.
Let's see what it says if I
It's
go.
too packed during third lunch in the cafeteria. I just feel like it's nasty when it's just all here.
Like, so
Really, the highest percent chance
It's
is
just packed.
just look at the Weather Channel, and they can be completely wrong. You know, those people get paid to be wrong all day long.
I want to.
Noon noon to 4 is the highest percent chance
Yeah,
of
I'm never
rain.
right.
I'll put
Like
one
you
on
did
one and
Friday.
do it over here.
Everyone going out.
All right, so mass and weight. One of these we will use regularly this semester, and one we will really not talk about at all, okay? Weight is the one we are not going to spend any time with. Now, if you were taking physical science, we would use both of these, and we would talk about the differences and use both. But we are only going to focus on mass this semester. Somebody tell me what mass is. It's not.
I forgot the definition of
I'll deal with the surface area, like how much.
I know what weight is. I know what-
Okay, well, that's good. At least you know that one. Something.
Is weight the amount of gravity pushing down?
Okay, you're gonna go in the right place for gravity. Hold on, hold on, let's get careful. You're getting warm.
Oh,
You gotta change a word. Take out the density word, put in a different word.
Matter an object.
Amount of what?
Matter.
There you go.
Wow.
I just killing all of y'all.
All right, so it's the amount of matter
Competition.
I forget it's called.
in an object. Alright.
Always been real.
Now, weight is the one y'all said you remember. So, it's the measure of what? It's the measure of gravity
Doing this job.
pulling on an object. Now, notice I didn't specifically say Earth's gravity. In this definition, I made it a little more generic because all objects have gravity, okay? It doesn't just have to be the Earth's gravity. Now, believe it or not, there is a law that says all objects have gravity. At the moment, if I pick on Daniela, The whiteout has gravity, the pens have gravity, that stack of cards have gravity, the eraser, the calculator, the notebook, the desk, she does, the floor, the tennis balls, all of it has gravity. They're all exerting it on each other. Why can she not feel all those other objects exerting gravity on her? They're too small. All right, gravity is based on size and distance, okay? And they're all very small. Gravity has to be, or is felt based on the mass of something. So you know that gravity here on Earth, well, I shouldn't say that. Maybe some of you know that gravity here on Earth is roughly 9.8 meters per second squared. So if you consider the size of the Earth in relation to the moon, we know the gravity on the moon would be what? More or less? Less, because the moon is a smaller celestial body, right? So if we consider the size of Jupiter when compared to the Earth, what would we expect about Jupiter? More, because it's a much larger planet, right? So if we went to the moon, what would happen to our weight? We would weigh a lot less. We would be able to jump with much greater ease because there's less gravity, and I would love to go to the moon because I would weigh a whole lot less. Now, if we went to Jupiter, on the other hand, what would happen?
We're more.
We would weigh much less. You will never catch me on Jupiter. Okay?
Their personal still look the same. It's just,
Yeah, we'll look the same. We just ain't gonna weigh the same.
That's gonna be
All right.
weird, like,
Now, so if I was to ask you, what is the difference between mass and weight? Can you tell me? And don't tell me the definitions. I know the definitions.
Okay, so.
I love when y'all tell me the definitions again.
Oh,
That's
oh.
never the answer when a teacher asks you the difference between something. They're never asking you to restate the definition, by the
Well,
way.
technically you kind of are.
That is never the answer.
Okay, so, yeah.
Never the answer. That's a BS answer, and most of us don't want to hear it, and most of us mark it wrong.
Is it related to how you said weight focused on, I mean, it's like direction?
Mm-mm.
So weight is like the.
all matter
difference
has
of-
weight,
Nope.
no?
Wait,
Come on, not all matter weighs, amount
Wait,
of matter.
So this,
mass can be
weight
measured.
is,
That's can be measured.
it's hard to reword.
I think it both be measured.
This is right there, like you did, like, just can't help it but say the definition.
It has nothing to do with the definition.
I know,
Is
but.
it like weight is a measure of what's happening to the object rather than mass being what the object
It's
is?
what it looks like, no.
Am I close?
No. Doesn't have to
It
do,
sounds nice to know.
okay, weight involves gravity and mass does not.
Weight involves gravity.
Okay?
Oh,
my
Go
God.
somewhere with that. Go somewhere with that.
And run my,
I'm gonna
I
have
need to go somewhere with that.
I know, see, it doesn't have to be about complicating stuff, as long as it's.
Right, Ms. Lowe taught us.
You still don't want to get any points for that, but what does that tell us?
It'll give you points for it.
It was right. Take
I'm telling you to go somewhere with it now.
Okay,
Take a sip.
So weight involves gravity
Oh
and
my
mass doesn't. So what does that tell us? What does it mean?
they're making a remake of the magic
Math,
school.
gravity.
It's
Oh.
For real?
about Miss Burnham's younger
Hush.
sister.
So.
So I put Danielle in the spaceship because she's irritating me, and I send her to the moon. What's going to change?
Her
Oh, she
weight.
won.
Her weight's gonna change your mass will not.
Okay.
Oh.
Yes, it is.
So mass does
Well, at least ties it in.
not change with location.
Oh, so no matter where you are.
Weight does. All right, so weight depends on location. Mass does not. So if I stick Daniela in a spaceship and send her to the moon, her weight is going to fluctuate based on the gravity that's available. Her mass is not. The only way I can change her mass is to chop off parts of her body. All right, if I cut off her legs, her mass will change. Otherwise, it's not going to. I can cut her head off too, that'll work. Now, short of that, her mass is going to remain constant. Her weight will change based on her location. Questions? Fabulous. Everybody have what they need. Let's talk. Huh?
We overthink everything.
It's the plight of being a teenager.
Not really.
That just got really deep.
All right, we're there now?
Yeah.
Okay, when you got, Lewis.
My hand.
All right, let's talk physical properties. Now, since we're talking about our blue chart, most of the things we've been working with the last couple days, density, heat, specific heat on your chart, are physical properties. So we're going to hit some highlights with physical and chemical properties. All right, physical properties are properties
What are properties?
that can be observed without. If you don't shut up about the bus, you're going to be sitting out in the hallway by yourself. All right, properties that can be observed without altering the identity of a material. We're going to talk about what properties are in a moment, dear. Be patient.
Oh,
Now, once we get caught up, we need to talk about what properties are for Danielle.
see, now I'm just telling because I wrote down what you were saying and not what I was writing.
Identification.
Ideas.
Today's not a good day.
It's really not.
I had someone tell me yesterday they were watching our first period video on YouTube, and they said that we're a whole lot more chatty.
You should come to fourth period. It's like a tomb in here.
Yeah, she said that they're silent.
They are.
They were-
For the moment they get in here to the moment they leave. I can't get them to talk.
Really?
Well, at least you have more class engagement with us.
Anything in Alexis is in that class.
I can't.
Alexis is in there. How's it working quiet?
Because it's ball.
It
No,
is.
but Alexis.
It's like a tomb.
They're
Why
scared
should
of
not?
ball. Well, I know it's ball in the pool.
You see what we do?
So which do you prefer? Yeah, this one don't play.
Y'all are more entertaining than they are.
Or
Rephrase. Daniela is more entertaining than you.
No.
Daniela
It's
is
not
full
just
of
you.
herself.
It's
but-
me.
Fourth period lasts forever.
Fourth grade, that's what.
Yeah, fourth period is a
I should
long
come.
period.
You should invite me one day to come with your team.
I'm not even sure you could get fourth period talk.
Really?
Really. All right. So if we look at, let's just say my black table up here at the front. Pretend there's nothing sitting on it. Don't tell me when I ask you for a property it's junky. All right.
It's pretty deep.
It's Woody.
Now, a property is just a characteristic to describe something. Now, what could you use to describe the table?
Solid.
Okay, it's state. So, saying or describing its state would be a physical property. Being able to say, for example, that it is a solid is a physical property. What else could you tell me about it?
It's black.
Big.
It's what?
Black.
It's color. Okay, color would be a physical property. All right.
Size.
All right, size. Somebody said big, so size would be a great physical property. All right, give me something else. Think about some things we've measured.
Material.
All right, it's material.
Wood. Ice.
All right, instead of wood, let's say like texture. Okay, what else? Think of things you could measure about it that we've done in the last week.
Clean.
It's volume.
All right, length, volume. All right, I heard mass. Remember, I don't take shorthand.
Weight count.
Sure.
Heat. No.
What kind of heat?
What's the word? Specific.
Specific heat.
So specific.
I know what you meant. All right, give me something else.
How much it feels good. I'm good enough. Not punch polish, it's not polish.
Oh, what is it? I just said the word. It just came in my head.
That's all we got?
Yeah. There's
No.
more.
How many beams they got?
Like shape.
Sure.
Oh.
Oh,
How many legs? That one.
Not everything has legs.
Take a minute.
Something that's generic that you could use to describe any object. I mean, the object you're going to use in lab does not have legs.
Location?
What it do?
What it do? How many years have you had English? Which English teacher do you have? I need to go speak to them. You need a little more grammar in your English lesson.
I think I have Miss Baker and Miss Van Leyenham.
Who do you have this year?
I don't have it.
This next semester.
They didn't put me in no English.
They did put you in no English class.
Yeah, I dropped it.
Clearly, we need to have that rectified. Okay. Physical properties only.
You should have me a chance.
Now, notice what I said here. Physical properties only can be classified as intensive or extensive. So in a minute, when I'm talking about chemical properties, are we going to talk about them as being intensive and extensive? No. It says physical properties only.
What was your question though?
I said in a minute, when we're talking about chemical properties.
Oh, no.
That's right. We're not going to label them as intensive and extensive. We're only going to talk about physical properties as being intensive and extensive. So, intensive depends, does not depend on the size or the amount. It means it would have that property regardless of how much you have. If you cut it into half of it, or if you cut it into thirds, it would still have that same property. It wouldn't change the property. Okay? Now, extensive does depend on size or the amount. Okay, extensive does depend on size or amount. So, if we cut it in half, the property would change. It would no longer have that same value.
So like tearing a piece of paper in half, it would still have the same properties.
Yes, I'm getting ready to go back and we're going to label those that we just have to illustrate. Are we caught up?
Or 2 years since freshman year.
I take one every once in a
I
while.
took one last week.
I take one when I can.
Really getting enough sleep at night. So they don't take a nap during the day.
I don't know. It's just something about my bed. Like when I get in, I just.
At least you got a left.
Are we caught up? Y'all are pitiful.
Well, we know you'll listen at the end of the year.
Yeah.
Yeah, at least you're like getting responses or something.
At least you're like when you come from our class, you're waked up.
And then we talked to people like,
No, she went from our class to a migraine. That's what happened.
Yeah.
I do not give people migraine.
You don't, trust me. Now, if we look at the state, if you cut my desk into thirds, would it still be a
Really
solid?
bad.
yeah.
Yes.
Then that is an intensive property. It doesn't change based on the amount that's present. Okay? It's not going to change its state if you cut it in half or into thirds. Okay? Now, its color. Will the color of the desk change if you cut it up?
No.
Then it's intensive. Will its size change?
Yes.
That's extensive then.
Hey, Jordan. I'm sorry.
Okay? Will its shape change if we cut it up?
Yeah.
Then that's extensive.
never get to answer anything.
Well, jump in there. All right? Texture. Will its texture change? Will the smoothness of the desk change? No. Now, the edge is where you cut it clearly, but the rest of it's not going to change. So I would say that's intensive also. Now, what about its length?
Yes.
Yes. Generally speaking, those kinds of things are going to change. What about its volume?
Yes.
So there's two different pieces now.
Yes, because now it's going to be two different pieces or three different pieces. So if you put it all together, the volumes would be the same, but the volume is generally going to change. All right, what about its mass?
No.
Yes.
Remember, you put part of it over here, you put part of it over there. Is the mass going to change?
Yes.
Yes, the mass is going to change. All right, what about its weight? Yes. What about specific heat?
No.
It's still the same.
No, it's still.
It's still the same material. Remember, where are your specific heats found?
Oh, inside.
Reference table.
In reference tables. They're not inside. All right.
Reference table.
If you look up the specific heat, they're on your blue sheets. Do the specific heats change? Do the specific heats on the blue reference table change?
No.
No, they're constants. They never change. It doesn't matter if the mass of the problem was 5 grams, 10 grams, 20 grams. The specific heat does not change. Because the specific heat does not change, it's intensive. Okay? Now, what's besides specific heat on that page that you guys didn't bother to write up here? Density. Okay? Density is also going to be what?
Intensive.
Intensive. A lot of people pick extensive on the test. But again, where is density on those charts? It's on the reference table. Does the density change? No. The size of the sample might change, but the mass and the volume are proportional, so it's not going to change. It's an intensive property.
So like a tree and a desk have the same density if they're the same.
If they're made of the same wood, yes.
So two oak wood, right, the same
That's
concept.
awesome.
So let's say a table would get an oak wood.
If it's the same type of oak, yes, they should have the same density. But if it's different types of oak, then the density can vary slightly, yes. But if you have mahogany and you have oak, the density will be different. All woods do not have the same density. But if you have the same kind of oak, yes, the density should be the same. Okay?
Just while blowing my mind on a daily basis.
Huh?
Just while blowing my mind on a daily basis.
It's not my intention.
I learned something new every day.
All right, chemical properties. All right, so chemical properties will alter the identity of a material. Now, these we're not going to make a very long list of, okay? Mainly because y'all just don't know a whole lot at this point. Some of y'all will know more than others. We're going to list a couple that are very common that you guys can relate to. Make sure I haven't skipped anything I want to do. Nope, I'm not doing any of that. Done that. Yeah, we're in good shape. All right, one that we'll spend a lot of time with this semester is reactivity. All right, probably more than you'll ever want to know in your lifetime. But like I told my daughter last night, this is just a hoop y'all have to get through because colleges want to see it on your transcript. Most of what we'll do in this class is useless. You will never need to know it in your lifetime. Physical science is a much better course in terms of overall life skills, but this is the one they want on your transcript. Huh?
Right,
No,
nobody
no,
knows.
y'all, they're like, you're gonna use all
Right,
of it.
everybody, just take chemistry, just take chemistry.
I'm sorry. It's a hoop. You just got to have it for your transcript. If you're never going to major in science, you are never going to need this in your lifetime. That's just the reality of the world that we live in. Sorry. I didn't mean to crush your dreams. I mean, if you're going to major or you need something in a science field, you will probably have to have a chemistry class down the road.
You wanna know what
But
I wanna
if
do?
you're going into something like I was probably going into, you're never going to need this again.
Might need it a couple times.
Yeah, she's gonna think about the periodic
Yeah, she's
table,
gonna
once
think
she's
about
on
that.
that, she's gonna be like,
You know, on Broadway, maybe you'll do something sciencey in one of your plays. You might need it.
I could just be Bill Nye.
You could. You can take over from him when he retires. All right, flammability. You know, when you talk about decomposition, you know, the ability to decay. Okay, any of those types of things, maybe oxidation.
Oh, yeah, I heard that word.
All right, most of you would probably think of it as rusting. All right, any of those kinds of things would fall under chemical properties. Now, this is probably the area that most people will struggle with because they're like, I don't know how to tell if something's physical or chemical. And we're getting ready to talk about physical or chemical change. And this is where students struggle, but I'm going to give you 5 things to look for. If any of those 5 things happen, then it's chemical. So I'm going to give you a way to figure this out because most people have absolutely no idea. Now, before I do that though, let's practice something real quick. There's the backside. I want to do the front. I want to do the front. Yes, ma'am.
It's an oxidized, whatever you say. Yeah. Doesn't it turn orange? It's like things that.
Right.
Yep.
Rust.
Right up there.
It's all good.
It's only 9.
That don't mean nothing. Is it rusty?
It's all good.
Okay, well,
923.
It's all good.
Well, you said you wanted us to be.
I want you to do the front with the table.
it's 8.
All right, so in the columns, let's say it doesn't work chemical property. I just want you to put a check under which one you think it is. Someone we talked about, someone we didn't, because you guys were having a, let's do the one with the chart. I don't want to do the backside yet because we haven't done physical or chemical change. All right, I just want you to put a check real quick under which one you think it is, because some of these you're like, I don't know, as well. You want us to make a bigger list? So we didn't do all of these. So put what you think. It shouldn't take you but about 2 minutes.
I don't know.
I would remember these.
Good. Put a check there.
I don't remember that.
Boy, that was
I know.
Well, I see what kind of useless email people send.
I looked up.
I can already tell from right now it's not going to be my day.
No days every day.
I always have bad days when I come to school.
Way often.
Every
That
week.
one, I was like Alexander, the terrible, horrible, very
Oh,
bad.
yeah, I
movie.
saw that movie. I actually liked it.
I feel like
I never watched the movie, but I read like the book when I was little.
I have a good day until I get to
Oh,
second
you feel like
period,
something
and then it
is
just like
wrong.
goes downhill.
Like, if you need
And then whenever I get out of it, it goes back uphill.
Like a roller coaster.
She really doesn't like me.
She doesn't like anyone.
Yeah, she does.
She said, I don't.
Speak for
she's like, I
yourself,
didn't
she
ask-
loves me.
What are we supposed to be
I didn't ask
doing?
you.
Oh.
I'm pretty sure it's not that discussion.
What do we do for that?
You've already wrote them all and answered them?
I think so. Wait, what do you mean, right?
I mean, like put a check in all the boxes.
Oh, yeah, I think I got them right.
Okay, then just be patient while everybody else finishes.
Supports combustion.
I was like,
And don't do the back yet. Just sit there for a second. It won't be much longer than everybody will be done. All right, you there?
Yes.
Let me grab one so I have the questions. All right, so question 1 says, it says, blue color, what'd you say?
Physical.
Good, density, flammability, solubility.
It's physical.
Solubility is the ability to do what? Dissolve.
Is it water that starts dissolving?
It is. All right, solubility is the ability to dissolve, and it is physical.
Watch it go down.
All right, reacts with acid to form hydrogen.
Chemical.
Good, supports combustion. That
That
is chemical. We'll talk about combustion, learn how to write combustion reactions in a couple weeks. Sour taste.
Physical.
That is physical. Some things just taste sour, some things taste sweet. That's just a physical property. Melting point.
Chemical.
Physical.
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 Yep. Yep.
Cologne told me that it was.
Oh, that's cool.
Oh, yeah, mister.
It's a physical property.
She thought you were wrong.
Yeah.
Yes, you did. It's a physical property.
She's
And if you want to know melting or boiling points, they're listed on your blue sheet
Oh,
on the
yeah.
first 2 pages. Alright, it reacts with water to form a gas.
Chemical.
That's chemical. It reacts with base to form water.
Chemical.
That is also chemical. Hardness.
Physical.
That is physical. Some things are naturally harder or softer than others.
Like that's it.
Yes, that is very true. You may be familiar with the Mohs scale from earth science if you talked about the hardness of rocks. Some of the chemicals on the periodic table will be softer, and some of them will be harder than others. We'll talk about those when we do the periodic table. They can neutralize, or boiling point, sorry, jump point. Boiling point,
Physical.
that is also physical. It works like melting points, it will be physical. Can neutralize a base.
Chemical.
That is chemical. If any of you have heartburn or parents have heartburn and they take antacids, that would be neutralizing the acid in your stomach. Alright? Luster and shininess, right? That is physical. And odor. That is physical. Some things naturally have a foul odor. Okay, some things don't, some things do. Alright. So we need to finish physical and chemical change so that tomorrow when you get here, we can do the lab first thing. I don't think we're gonna get to it today based on the time. Alright, physical change. Alright, physical change is a change that does not alter the, and I'm just gonna say identity of materials again. Okay? You keep the same materials you started with. And I'm emphasizing that because I'm going to show you something different in chemical in just a minute.
So balling up a piece of paper.
Yes. Okay. So if we go with Daniela's example, balling up paper is a physical change. A lot of people will put things like tearing here, grinding, shredding. All of those things fall in the physical category because you're not changing anything. The things that people struggle with in physical change are state changes. So what do I mean when I say state changes?
Like gas or liquid.
There we go. This is where people go off the rails with physical change. When we have a gas to a liquid, for example, and we're going to talk about these later in the semester because being able to tell me what the state changes are is not my curriculum. You should have known this long before you got here. You're going to have to calculate how much heat is lost or gained. You're going to have to be able to read it off a graph. And there's something else we got to do. I haven't seen your moment at the moment. There's 3 things. Oh, you got to be able to tell me if heat's absorbed or released. And we'll do that later in the semester. But just labeling what the state changes are, you should already know that. So just as a refresher, gas to liquid would be called what?
Condensation.
Okay. I was worried there for a second.
Wait, what?
Okay. The opposite of that would be liquid to gas, which would be called what? Okay. Solid to liquid would be?
Melting? Melting.
The opposite would be liquid to solid, which would be?
Freezing.
Okay.
Wait, it doesn't have to be freezing.
No,
It just be
I'm just kidding.
solidifying, right?
Yes. You could say that, which would be fine. You want me to write that too?
Yes, please.
I'd be glad to.
Always.
I don't know how to spell it. It's probably spelled wrong. Spelling's not Ms. Wall's strong suit, so y'all fix it on your notes.
I'm
I can't spell.
Can't spell it.
Does earlier.
All right. Solid to gas.
Magic.
Isn't it like,
Sublimation. Okay, dry ice will sublime. It will go from a solid directly to a gas. And most of you probably don't know gas to solid. I'll teach you that one when we get there.
Solid gas can.
Wait, hold on, did you just use the word sublime?
Yes,
What's the line mean?
Sublime?
Oh, wait, never mind.
when it goes from a solid to a gas.
Or like a-
Dry ice will sublime.
like if something's
Will we ever get to that salt? Dry ice.
I don't know, I guess I could buy it at Harris Teeter when I'm there one day, but I don't generally shop at Harris Teeter very often. I tend to find them expensive.
Liquid nitrogen.
I don't have any. All right. So any of these things that occur are going to be a physical change. Now, students struggle with these, and I understand that. So how are you going to be able to figure out if it's a physical change or if it's a chemical change? Well, chemical changes have 5 indicators we can look for. And if you don't see one of those 5 indicators, then it's not going to be that. So sometimes students struggle with these, like dissolving or solubility. For example, making Kool-Aid. Some folks look at that and go, well, I know that's a physical change, Ms. Wall. We just dissolve some sugar. Some students struggle with that. So the 5 indicators make it really easy for some people because they're like, oh, I didn't see this, or this. Oh, it's got to be a physical change. So what are these indicators I speak of? Does everybody have what they want off this board? Okay. Okay.
So state changes are all.
All physical. Because, for example, if water freezes, is it still water?
Yeah.
Yes. All we've done is change its state. It still has all the same properties that it had. Nothing has changed about it. It's just in a different state. It's not going to have any of the same properties. That's what we're getting ready to talk about. And I'm going to give you an example to illustrate that you can all relate to.
so solubility.
That's physical. For example, if you dissolve and make Kool-Aid, let's not even put in a flavor. So if you put sugar in water and the sugar dissolves, the water's going to taste how?
Sweet.
Sweet. It's still going to have the same sweet taste that sugar will have because the sugar just dissolved in the water. Okay? So that's why it's a physical change. Everybody caught up? Just like sweet tea.
Ew.
I remember one time.
Yeah, ew. Anything you got to add that much sugar to make it taste good couldn't have tasted good to start with.
I don't understand who fascination with sweet tea in the South.
Just because I
Are you?
think, I don't think people don't have.
Really?
Sweet tea is.
I like it.
Tea should be kept warm, not cold.
No, don't ever drink sweet tea warm.
Don't ever drink tea, period.
Alright.
Chemical change. Chemical change is a change that completely changes the identity of a material and gives all new properties to new materials. So you're getting new materials and you're getting new properties. Nothing you started with is going to be left, and nothing you started with is going to have any of the properties that you had. Okay? Everything is changing. Everything is going away. Now, to illustrate that, we're going to look at sodium plus chlorine to make salt. Okay? Everybody in here at some point in your life has used table salt. Got it at home, most likely. Mom's probably said get it out of the cabinet and put it in the salt shaker, maybe. Now, if sea salt would look similar. Now, sodium is a silver metal that explodes in water. Cannot be sitting on my desk. there's moisture in the air. Okay? If I had a sliver of it sitting on the desk, it would go kaboom. Cannot be exposed to air,
Tiny.
much less put in your mouth and blow your head off. Might be kind of entertaining for some of us, but
Yeah, that would be awesome.
can't be exposed to air. Explodes in water. Chlorine is a yellow, poisonous gas.
Like mustard gas?
Very similar. Like just a little bit of it, drop dead. Yes, very poisonous, very deadly. Okay? Now, clearly, sodium by itself, chlorine by itself, we cannot be exposed to those two elements. All right? Highly deadly. However, everybody in this room has had white, granular, solid, safe to eat table salt. Now, clearly we can't eat a salt shaker a day for 25 years and claim it's safe to eat, but we can all sprinkle some on our lunch today and not have to worry about keeling over at the lunch table. Right? Now, when those two elements react, do they keep any of their original properties?
No.
No. All of those properties go away, and we get brand new properties when they chemically react. Now, how do we know they undergo a chemical change? How do we know this? They're going to have one of these 5 indicators. It's actually going to be the first one I'm going to put in the list. So catch up with me, and we're going to label the 5 indicators. We have 12 minutes to get them done. We got to get them done. So tomorrow when you get here, we can start with the lab. Because I don't want to have to talk when you get here, other than do the opening.
About that last one though.
Hard work.
Is that a U?
Where?
Granular.
Granular. Granular.
Oh, like a W.
I was.
Hey, one on like 5 years.
I didn't.
I don't. Oh, yeah.
5 years.
It's an exaggeration. It means that.
You there? All right. So what are these 5 indicators? Okay, 5 indicators of chemical change that I speak of. Number 1. Okay, let's try that again. Number 1, 5 indicators of chemical change. Okay, that didn't work out so well. Number 1, the production of light. And that is what happens when you mix sodium with chlorine to make table salt. You get a big burst of light. Okay? Now, I'm going to tell you now, when you're working on the lab tomorrow, you will see all 5 of these somewhere in the lab. So don't tell me and when you're answering the questions, nope, didn't see any of these, Ms. Wall. You should see all 5. Okay? Number 2, the production of a gas. Now, how will you know that you produced a gas tomorrow?
You'll see us smoke.
Really? You pass gas. How are you going to know that somebody passed gas in the room?
Smell.
Do all gases smell?
No.
Okay.
It sounds like that.
You might hear it.
Deadly, but.
You might feel. What else? It's an indicator in a chemistry lab.
Wait.
Color.
Put a baby in a bathtub.
Sound.
How do you know the baby's going to have gas? Bubbles. Bubbles.
Oh, beans.
All right. Not all of it's going to smell. All right. So, change in color. Now, I have to qualify this. It has to be an expected color. If you put grape Kool-Aid mix in water and it turns purple, that is not a color change. If you put red dye in water and it turns red, that is not the change of color I'm talking about here. If you mix two clear liquids together and it turns pink, that's a change in color that's a chemical change. Okay? If you mix purple Kool-Aid and you mix clear water and it turns light purple, that is not a color change. If you mix your normal art colors together, like you mix yellow and green, what's yellow and green make an art?
Orange.
And it makes orange, that is not a change in color. It don't make orange, does it? I was thinking, that doesn't make orange.
Oh, wait, come on. It's yellow and green, it makes.
Light green.
No, the primary.
Yeah, yellow green.
No,
You said blue.
Yellow and blue make green.
Oh, yeah, she said yellow and green.
Like, what's he talking about? All right, if it works like we're supposed to in art class, it's not a color change. It has to be something unexpected. Okay?
So if I wake up blue.
All right, if Daniela wakes up tomorrow as a Smurf color, then it's an unexpected color change. That's a chemical change. All right? Change in temperature. Now, when I say change in temperature, I mean we didn't put it on the stove and heat it. We didn't stick it in the refrigerator. It changed on its own. Now, there are two temperatures you should remember from biology class. Anybody remember what they are? They start with E's.
Hold on, give me a second.
Biology?
Maybe they didn't. Maybe it's first science. Starts with an endo word, an exo.
Exoskeleton.
Maybe not.
Endothermal.
Yeah.
That was
Earth science. Okay. Endothermic. What does it mean?
Endo means outer. Oh, no. Endo means inside.
Heat is absorbed.
And heat is lost.
Heat is released. All right. So if heat is absorbed tomorrow, how's this going to feel to the touch when you touch the baggies of the test tubes? And yes, you're going to need to touch things because you're not going to know how it feels if you don't touch them. Yep. It will feel cool or cold. All right. And exothermic will feel, it's going to feel warm. I'm not going to give you anything that's going to feel hot and burn your hands. Okay. But you're going to have to feel the test tube and the baggie to see how they feel. All right. And the last one, number 5, is the production. Let's say formation. I don't like production. Formation of a precipitate. Now, we are not in our science class, so a precipitate in chemistry class is not sleet, snow, rain, hail, or any of those other objects. A precipitate in chemistry class is a solid formed from 2 liquids. Now, I have simplified that a little bit because y'all don't know the second half of the definition. It should really be from 2 aqueous solutions. We're not sophisticated enough to know what 2 aqueous solutions are yet, so I'm just going with 2 liquids at the moment. We'll come back to this at the very end of the semester. But, no, I meant the whole group. All right, the formation of a liquid or a solid from 2 liquids. So, tomorrow if you mix 2 liquids together and it makes a solid, you've made a precipitate in chemistry class. So, when you mix Kool-Aid together and you're looking at, is it a chemical or physical change? You ask yourself, yep, did I produce light? Did I make a gas? Did it change color in an unexpected way? Did the temperature change on its own? Did I make a precipitate? If I didn't do any of those 5 things, is it a chemical change? Okay?
So you can only do 1 out of the 5.
You just need 1 out of the 5. You don't have to have 2 or 3. You only need 1. So when you're asking yourself, something melted, is it chemical or physical? Did it produce light? Did it make a gas? Did it change colors in some way? Did it form precipitate? Did it change temperatures on its own in an obvious way? If all of those answers are no, then it's not a chemical change. Okay? Questions? Now, we're not gonna have time to start the lab simply because I only have 4 minutes. For homework, let's talk about what I want for homework. 'Cause I'm gonna alter. I can't remember if I typed these directions on there or not. On the back side of the worksheet. Find question number 1. I think I did. Can't remember. All right, so number 1, I want you to tell me if it's physical or chemical. Sodium dissolves in water.
Physical.
So write physical or write P out to the side. All right, number 2. Hydrochloric acid reacts with potassium hydroxide to produce a salt, water, and heat.
Chemical.
All right, right? Chemical. Now this is the second part I want you to do. So if you tell me it's chemical, I want you to tell me what the indicator is out of those 5. Some of them may have more than one indicator. Some of them will only have one. What is the indicator that's in that description?
Precipitate and it produces.
Okay, do you produce light? Do you produce, I don't even care if you just write the word down. Light, gas, color change, change in temperature, precipitate. Which one do you have? Light, gas, color change in temperature, precipitate. And number 2. Hydrochloric acid reacts with potassium hydroxide to produce salt, water, and heat. All I read there is heat. It does not say anywhere that we produce a solid or a precipitate. Well, you produce salt, but it doesn't specifically say that it precipitated. You just made salt. So if you said precipitate, I could probably adjust simply because y'all don't know a lot yet. So if you said precipitate, I can work with that. But precipitate and temperature change are probably the only 2 I could work with. Okay? So the rest of them, if you say chemical change, tell me what the indicator is on those answers. Okay? That's your homework.
And then if not, you can just leave it as.
If not, just leave the rest of them. If it's physical, don't tell me any indicator. Because there won't be one, the whole sheet. Okay?
I'd be wrong about physical and everything.
Can we spell
It's not physical on all of them, okay? I'll just give you a hint. All right? Put your calculators in the bucket. Say what?
Can we put like here?
Yeah, you can write here, so you don't have to write the word out. Is there anybody else makeup work in here? I know I have a couple people on 4th Street. If you are planning to come today for makeup work, and I think it's only 4, but I'll be here today at about 4:10, and then tomorrow I'm still 1.
Get it. Get it.
Some rest.